Okay, hi, good day, everyone. Welcome back to another Devfest event. We are Devfest, GDG Caribbean Devfest 2022, day three. And right now we're in Trinidad and Tobago. This is TT's day. This is GDG Port of Spain's fourth Devfest. I'll be your host, Nicholas Mendez, your loyal host for the Devfest on the Trinidad side of things and Devfest Caribbean. And we have a nice lineup of talks that we have for you in our virtual track. Our virtual track is just three sessions. And then later on, we have our in-person track. Unfortunately, we weren't able to get the hybrid to work out. So those who are able to join us at the Dalai Lama at One Woodbrook Place, we look forward to seeing you all once again in person for our in-person session. Okay, so I'm gonna go right into our first talk. Right, our first talk is Obika, right, who is no stranger to these DevFest events. Right, but I'll still give you his bio. So Obika Jalano his talk is on secure and infrastructure as code. Right, Obika is a cybersecurity consultant. He has over 10 years of combined public and private sector experience in criminal investigations, forensics, and information. He has been instrumental in the development and implementation of various information security risk methodologies that supports ISO 27001 and PCI DSS standards. So as I said before, Obiko is no stranger to these DevFest events, and we always happy to have him on board. My motto is that we always, as developers, should put security first, and that's why we tend to have him go first at these events. Right. So without further ado, we're going to show Obika's session. Let's get
next year.
Let's get this here. Welcome back to the DevFest. I know you're a long time speaker. You're no stranger to the event.
Oh, definitely. Yeah. Good to be back next year. How many years is that? What, 6, 7 years now?
I think supposed to calculate. I really think it feels like 6 or 5 years, but I think it's just the fourth one. Unless
sure it's a little bit more, but
I think the first one was 2018.
First one was 2018. Yeah. So about 4 years. Yeah.
Yep. So
it seems like it's a lot.
Yeah, it feels way longer. It really does feel way longer. But yeah,
because
thanks again for joining with us. So what is your talk about today?
Okay, so today I'm going to be talking about securing infrastructure as a code. It's more or less within the cloud track, the cloud development track. So we'll be going over just, infrastructure as a code and security and best practices around using infrastructure as a code.
Awesome. So without further ado, you can take it away.
Okay, great. So hello again, everyone, to the Google Developer Group Port of Spain Devfest 2022. As Nicholas has said, my name is Obika Jelno. I am the manager of cyber services at KPMG CARICOM. Basically, what I do is I provide cybersecurity services to various clients throughout the Caribbean. And I cover topics anywhere from basic cybersecurity to even things like analyzing security architecture, business continuity, assessments, as well as penetration tests and forensics as well. So today, as Nicholas had said, we're covering securing infrastructure as a code. So I'll just dive right into it. For the agenda today, we'll be looking at just a couple of topics. I'm not going to go way in depth into infrastructure as a code, but what I would say is that we'll firstly, of course, answer the question, what is infrastructure as a code? Then we'll look at infrastructure as a code automation tools, infrastructure as a code in software development, and last but not least, the main topic, infrastructure as a code security. So what is infrastructure as a code? Here is a definition that I've found to be probably the best definition that explains what is infrastructure as a code. But to sum it all up, it is a provisioning process for IT infrastructure and to do it in an automated fashion, automated and by extension managed fashion. How it's exactly done is that it's done through human readable definition files. Those human readable definition files is what is used to develop and build the infrastructure. And then you use a tool, and that tool then goes and builds out the infrastructure for you, whether it be, now, before it became mainly around building infrastructure and cloud services. It used to be with physical servers. But nowadays, when you speak about infrastructure as a cloud, you do it for cloud services. So it's basically a tool to build, or basically the use of code to build and deploy large IT infrastructures on the cloud. For example, AWS, Google Platform, as well as Azure services. But it comes back again to the question, how does this vary, or how is this versus traditional types of deployments? So here on the slide, I have basically the traditional type deployment versus what is used for infrastructure as a code. And they have some similarities and differences between the two. So as you can see, the main similarities are between GUI interfaces. Both infrastructure as a code has a GUI interface, as well as the traditional way of deploying and configuring large IT infrastructures. And both tend to sometimes use version control in terms of a way of controlling the scripts, or by extension, in terms of infrastructure as a code, the files as it relates to that level of configuration and deployment. But where it starts to differ is just the way in which it's implemented. So with traditional type of deployment options, you have platform-specific scripts. So like Bash scripts, or when you're looking at Windows, you'll look at maybe PowerShell scripts, or CMD scripts as well. All of those scripts would be then used to deploy, your configurations, and by extension, your software, through copying, SSH, and so on and so forth. You also, for traditional, you have manual configuration, whereas in infrastructure as a code uses automation. Also going back again to the platform-specific scripts, when you're looking at infrastructure as a code, it doesn't really use scripts. It uses something called common data format files. So for example, JSON, YAML, it would use those files to build out your infrastructure. And then through those files, you then use automated tools to build out the infrastructure. Traditional also tends to use individual software, while infrastructure as a code uses the software supply chain. And what do I mean by the software supply chain? It would use SDKs, Docker containers, Kubernetes, and even cloud images to actually build out the infrastructure. And we'll go through a file later on to kind of look at how it does this. So ultimately, what are the benefits of infrastructure as a code? Well, obviously, the first thing is that it's an automation process, and it works across cloud environments. So, for example, Google Compute Platform, AWS, and Azure, each one through infrastructure as a code, you can build out your infrastructure across these platforms with just slight differences to the files, but they all more or less work the same, or at least in a similar fashion, depending on the type of infrastructure as a code tool that you use. There's a cost reduction in configuring large infrastructures. And when I say cost reduction, not only a monetary cost, but as well as an effort in terms of doing that configuration and building out of that large infrastructure on the cloud through infrastructure as a code. It integrates well with CI/CD pipelines, as well as there is a reduction of human error through infrastructure as a code. When you're dealing with the traditional deployment method, it was very, very prone to human error because of the complexity in which you required to build out these platform-specific scripts and the way in which you build it. whereas infrastructure as a code is pretty, what I would say, reduce prone to error. That's the best way to describe it. But there is a reduction in human error with infrastructure as a code as compared to traditional deployment. You're also with infrastructure as a code, visibility of your infrastructure across the organization. It's a lot easier to do that through infrastructure as a code. It can be imperative or declarative. I'm not going to go too much into it, but basically it's just a way in which you can build out these infrastructures. There are different ways in which you can do it through infrastructure as a code. It heavily uses source control and versioning, makes it a lot easier to control the infrastructure through Git, Mercurial, or even SVN. And then last but not least, it's easy to validate through code review and automated tests. So let's talk about quickly some infrastructure as a code automation tools. So when we're looking at automation tools, the automation tools are what the administrators and the developers of your cloud infrastructure, and I'm going to say cloud infrastructure or virtual infrastructure, what they use to actually build out that structure. Those tools, basically, what they do is that they take the definition files, they analyze it, and then based on what you write in those definition files, it then creates the different resources on your virtual environment to actually build out your cloud infrastructure. So these are I have here a list of tools, popular tools that are actually used in infrastructure as a code deployments. So when we're looking at probably the most popular tools, Ansible and Terraform are probably the most popular, but you also have CF Engine, you have Chef, you have Otter, Pulumi, Puppet, as well as SaltStack. All are open source, all have different types of ways in which they program out the files, but at the same time, the majority of them work across platform. And when I say across platform, it could work with Google Cloud Compute Platform, it can work with AWS, and it could work with Azure. All are heavily documented and all are well maintained. The only non-open source or proprietary tool is Otter. Otherwise, everything is freely available and the source documentation is there on the internet. So here I have an example of what infrastructure as a code definition file looks like. So this one is for Terraform. It's a Terraform JSON definition file for Google Compute Platform or Google Cloud Platform. As you can see, it's actually a JSON file, and it lists out a couple of things, such as the provider. The provider in this case is Google, but you also have a couple of things as the provider. So let's go through what are the different items within this file that we could identify. So we have the cloud region and zone. So it actually identifies where the actual cloud instance is, which in this case is US Central 1, and the zone is US Central 1C. It has the project ID. It has secrets. So in other words, it stores secrets in the creds.json file. So there are secrets to help with access to the network. It also puts down 2 computing resources. And the 2 computing resources that you have here is you have a virtual private computing network called Terraform Network. And you have a Google Compute instance or VM instance called Terraform instance. The type of instance is a F1 micro. And as you can see, based on the software dependencies within that particular compute instance, it's using a Debian cloud image, preferably Debian 11, right? So you can see from this definition file, when it's then sent into Terraform, Terraform is now going to go into Google or into your Google account and it will actually go and it will build out this project. It will set up that virtual private network, and it will create that Google Computing Cloud instance, and it will interface it with our virtual private computing network as well. And this is what is beneficial as it relates to infrastructure as a code and being able to build out those large IT infrastructures on the cloud. So let's talk quickly about infrastructure as a code in software development. So how does infrastructure as a code fit into software development? Well, as I have said, you have your definition files, your JSON or your YAML definition files. And when you're building out your code, you will also build out your infrastructure as well, obviously. And that goes more or less into the develop stage. So during that develop stage, you tend to use items such as the IDE plugins, like TF-lint, which is for Terraform. It's a linting program for Terraform, or you have Ansible lint, which is a linting plugin for Ansible, right? Those plugins help validate your syntax, and I think sometimes those plugins also help analyze your static or your code when you're building out those definition files. Then you move on to the version control. And for version control, well, most of us use Git, but there's also SVN and Mercurial. What I would say in terms of security, version control is always good. And it also helps in terms of securing your code and being able to make a code traceable, which is always good under a security setting. You then move into your testing phase, and under your testing phase, you would have static application security testing as well as code reviews. During that time, you would do analysis on those JSON files using static tools, and we'll talk about static tools later on, and through manual or even automated code reviews of the infrastructure as a code to make sure you are within certain parameters as it relates to the definition file itself. And then you go into the release. The release stage is when you have your MVP or your most viable product. During this stage, you tend to sometimes do dynamic application security testing as well as penetration testing. You try to analyze and make sure that it's within some level of security compliance prior to you deploying. And when the deploying stage, you more or less put your definition code into Terraform. Terraform creates it, and then you have a cloud monitoring service that monitors the infrastructure to ensure that everything is deployed properly and your instance is working, and by extension, your application is working as intended. So that's how infrastructure as a code fits into your whole software development workflow. So let's reach onto our last part of the presentation, and that's in relation to infrastructure as a code security. So I have 10 best security practices as it relates to infrastructure as a code. If you follow these best practices, it would enhance and build the security of your application and by extension, your IT infrastructure on the cloud. So I'm just going to cover the 10 as best as possible with the remaining time that I have. But what I would say is that first and foremost, try to avoid using templates. Now, an example of a template would have been in that earlier slide that I showed you, the Terraform definition file. That's actually a template file. Try to avoid using those type of files because sometimes those files have errors in them and security weaknesses in them. If you are building out your infrastructure, my suggestion is go through the documentation and build it out as according to how it's listed in the documentation, and avoid using the template files as a starter. Right? Start off small, build big. After that, the next best practice that you should implement in your files in particular is to enable audit logs. Audit logs are very important. You should be logging on your cloud infrastructure. It is one of the best security practices in an incident. So if anything happens, you're able to track down where and when it happened, and you're able to resolve it. It's also, as it relates to security, logging is extremely important for security. So I would always, in any part of my presentations, always say enable audit logs. Have that traceability within your infrastructure, have that traceability within your code, and by extension, in your infrastructure as a code files. Number 3, utilize secrets management built into the tools. Do not hard code credentials. Hard coding credentials is probably one of the biggest mistakes that I've seen or I've come across when it comes to coding. Do not hard code your credentials in your infrastructure as a code definition files. Use the secrets management capabilities of the various tools that are available. Terraform has one. Use it. Always try and build your, when you're building your infrastructure, if you have API keys, if you have usernames and passwords, if you have any sort of information that requires to be secretive, use those secret management tools, secrets management utilities that are built into the tools. Number 4, when we're looking at best practices, you're looking at your project, always assign user access based on the principle of least privilege. So what do I mean by that? The user does not have more access, the user of the project or the person who is either developing or building the project or even creating your infrastructure as a code, make sure at any point in time they only have access as much as needed. If they go beyond that, that can lead to an insider threat. And if you do have an insider threat, it's very likely that person can take down your entire network or by extension, your entire infrastructure on the cloud. So always ensure access is based on least privilege. In other words, make sure that user access is only given to the functions that are required for a person to do their work, no more than that. Name and tag all your resources in your infrastructure as a code files for inventory tracking. So this is very important. When you're creating resources, and you saw it in the initial file, when we were creating that network and when we were creating that VM instance, we actually gave them names. There's also tagging tools sorry, well, I shouldn't say tagging tools. You can assign tags to resources. A lot of the infrastructure as a code tools have the capability to actually assign tags. So you can use those tags to group certain resources. That way you avoid mixing and matching resources and having clashes as well. It's also a good way of trying to be able to segregate your network, because when you're building out a virtual environment, sometimes you build out large virtual networks, and sometimes it's good to tag resources under certain networks within your virtual environment. That way you can know where certain VMs exist in a certain network on your virtual environment. Number 6, again, use version control for tracking of your infrastructure as a code files. Very important, extremely important. Always use version control. Always have that traceability on your files. Moving on, number 7, open source dependency checking tools. As I had mentioned, again, there is software dependencies in your infrastructure as a code. Those dependencies could be, well, we saw one which was a cloud VM from Debian. But you can have things like Python environments, you can have SDKs that you download off the internet and build into your infrastructure. It's extremely important that if you are pulling down versions of different types of software through your infrastructure as a code, always ensure that you have an open source dependency checking tool, Sneak, White Source Bolt, and there are others that are freely available that check for dependencies within your code. In terms of static analysis, as I had mentioned, static analysis tools try to identify misconfigurations and understand risks within your infrastructure of a code as a code definition files. You have different types of static analysis tools. You have TerraScan, you have Sneak, you have CubeScan, and then there are others as well. Always deploy these tools when you're developing so you can identify whatever risks or whatever misconfigurations you have within your definition files. Always use container image scanning tools. When you are building out these infrastructures, most of the times you're going to use Docker containers. You may use cloud images, as we saw with the earlier definition file. You may use other things. You may use different flavors of images, or you may have Kubernetes deploying pods on your infrastructure. If that is the case, always have those scanning tools. You have Clear, you have Trivy, you have Anchor, you have all these different scanning tools. What they will do is that they will go into the container and they will scan the container to make sure there are no vulnerabilities in the container, and so that you avoid using vulnerable containers on your infrastructure. As we have seen before, a lot of hackers, what they do is that if they're able to get onto Docker Hub, they change out images and they put compromised images. And when you take those compromised images and you put them into your infrastructure, it can have a backdoor in your infrastructure, and that gives the hacker a path into your infrastructure. So always use container image scanning tools. Most of them are freely available. You have some ones that are commercial, but some of them, like for example, Trivy is freely available and you can download. And last but not least, the last one as it relates to security best practices is always use dynamic static analysis tools to evaluate existing environments for potential security risks. Static analysis tools are like vulnerability scanners, as well as web application scanners. Those type of tools help understand your infrastructure, your computing infrastructure, your cloud computing or your virtual computing infrastructure. If you have an application as well as part of that infrastructure, as part of that deployment, it also helps in terms of ensuring that any sort of vulnerabilities or weaknesses are identified through the dynamic static analysis, through penetration testing, utilizing those tools. Some of those tools are actually automated. For example, OWASP Zap, there is an automation function that allows you to scan your web application prior to you deploying it on a cloud environment. Use those tools as a way of ensuring that you reduce any vulnerabilities to your infrastructure as a code, and by extension to any sort of web application that you're deploying as part of your infrastructure. So that comes to the end of my presentation. I'd like to thank everyone again for your time and for listening into my presentation. I'm pretty active on LinkedIn. You can see there on the lower part of the presentation slide my LinkedIn web address or profile address, I should say. So I'd like to thank again GDG for inviting me and giving me an opportunity to talk about security on a virtual environment.
Read, excellent. I really like this whole IEC stuff because with I have some experience with cloud. Every time I have to the system, and maybe I'll just go it and you just verify with me if my understanding is correct. When you go on a cloud, platform, you build a system. I need to make a database here. I need to put some ports. Need to configure that. Need to pull a VM here or a cloud function here. And it's basically you going through the different parts of the UI, clicking this, click that, click that. But infrastructure code here is basically specifying all the settings you need in one file. So you have it available to audit it. You can go and review it. You could do version control. And what you mentioned was really important in terms of you could put variables instead of putting in some
environmental variables,
secret
secrets.
management.
Yeah,
That's correct.
Yep, secret management as well. Yes. So the whole idea behind infrastructure as a code is just, instead of having that UI when you go into your cloud platform and clicking and dragging and dropping, you just basically build it out into a definition file. Now, I only showed one file, but you can also do it as several files and just link it into the main file, so that when you execute it on the tool will start referencing the subfiles and build it out where necessary.
Great. So then, because I mean it's code files, but it's not really like programming code. It's just code as in that it's just there's a structure and a format you need to follow. Is
Yeah,
that
so
correct?
it uses JSON and YAML,
Mm-hmm.
which are two, what I would say, definition type files or object notation files,
Mm-hmm.
and it's used in a lot of software development. So it's easy for programmers to just pick up and go with, because I'm sure programmers have written out JSON files and they've written out YAML
Yeah.
files as configuration files. So it's the same type of methodology. A couple of the tools use their own type of definition files as well. I think, if I remember, Puppet uses Ruby-based definition files. So definition files based on Ruby language. I may be wrong. I can't remember right off the bat, but I remember that there's some of them that use their own proprietary type definitions, but the majority of open source ones tend to accept JSON and YAML.
And that's great. So then your code review could also become like a security review, and you can kind of test, like have your DevOps people look at the infrastructure that you want as well, because everything is specified in one place, right?
Yes, everything is specified in one place. It makes DevOps a lot easier in terms of when the team is building it out. As you're building your code for your web application, if there are any changes as it relates to the actual infrastructure, you can build it in one time. And because you have the various static analysis tools as well as the dynamic analysis, and it fits into those code reviews as well, it just makes it even more easier to have a unified approach in terms of when you are doing your DevOps or when you're doing your CI, CD pipelines. It flows really easy, and it makes it very integrated and very, what I would say, centralized in terms of the entire development process, both on the virtual side as well as on the software side when you're building your application.
Yep, great stuff. So thanks again for starting us off with Devfest this year, Vika. Any last words?
This is what number four. I start off in the first.
I have to keep
uh,
security first. That's what we always say.
Yeah, I know. I'm accustomed to it by now. All I will say is, the world is changing, and with that change, there's change to the level of risk as it relates to producing these type of applications. So, even though I've talked only about security as it relates to infrastructure as a code, always ensure at any point of your development process you integrate security into it. You have seen a lot of hacks in the Caribbean recently, most notable the Massey one, which is probably the largest one to date. You don't want to be in that same position as that company. So ensure security is part of that development process from start to finish.
Thanks a lot again, and see you all in the next one.
Okay. Thanks again. Bye.
All right, bye.
Okay.
All right. All right, so I think that was a really good talk to start us off. It'll be, of course, coming in again with the cybersecurity stuff. He always gives good talks and really in-depth information on how do we keep or ensure that our systems are safe and secure. And that's part of the issues that we often see in the Caribbean, unfortunately. So we always want to make sure that we are a platform for that kind of advice and instructional content. So we're going to go right into our next speaker. It's another sort of pre-recorded speaker. So our next speaker is Anil Ramnanan, and he'll be talking about generating unique books with AI art APIs. Okay. So Anil is a software developer with experience both in web-based and mobile applications. He has developed applications using the Linux, Apache, PHP, MySQL stack, as well as Python and Flask. His most recent experience is with the development and implementation of applications on cloud-based infrastructure, such as Amazon Web Services. He currently holds certifications in AWS Certified Solutions Architect, Associate, and AWS Certified Cloud Practitioner. All right, so we're going to bring Anil's talk on stream.
Hi. Yeah. So today I'm going to talk about AI art generators. Um, things like we've heard about things like DALI and Stable Diffusion and being able to generate artistic works through AI. So I'm just going to explore some of that a little bit and go through like a use case of a little pet project that I was working on.
Great, great. As a matter of fact, all of our talks on Devfest this year happen to be AI related, and I know it's all the range we're seeing AI being placed in the context of art, development, open AI. The Chat GPT was out recently released and is doing a lot of amazing things. I wonder if you had a chance to
Yeah.
play with that.
Yeah. I mean, it's it's very interesting. I could see a lot of good things out of it, and a lot of strange things that could happen from it.
Yes,
So
it's definitely in the academic sense, and we also have our concerns. Okay,
yeah,
so you're basically a DevFest expert to the sport. You're no stranger to the event. Thanks again for coming, and I'm going to give you the
yeah, no
floor.
problem. Okay. All right. So my name is Anil Ramnanan. I'm a software developer and also a learning management systems administrator at UE Open Campus. I also, do a lot of work in open source and um, dabble in some machine learning stuff. So I've been doing work with like computer vision and that type of thing. So today we're going to talk about AI art generators, and I know a lot of people have heard about it. Have heard about being able to go online and generate your own works of art using just a few words. And so we're going to explore some of that and explore like a little pet project I was working on, how you could use that. So what is an AI art generator? So the thing about AI art generators is that they use machine learning algorithms, and what they do is they generate works of art. It could be music, it could be other types of art that are unique. Now, these generators are usually trained on a large data set of existing artwork, and it learns about uh, the different styles and techniques of all the different uh, artwork that is trained with. So it uses all of this information to create models where it can now create its own new original pieces of art. And that is the important thing to remember. When these when these AI art generators create images, they are new and original pieces. So how does it do this? Well, let's talk about the types of AI art generators. So first of all, a lot of what we're going to be talking about would be text-driven image generation, where a human inputs a request, gives a text prompt describing an image. So I want to see sunset on a beach, for example. The AI then interprets the prompt to determine what the image should be. And then it generates a new unique image based on its interpretation of the prompt. So it would go through, you know, its models and its algorithms, and the neural network would basically decide, okay, so this is what sunset on the beach is supposed to look like, and generate a picture for you that is a unique image. So how does it do that? Well, there are a few different techniques that are used. The first is using generative adversarial networks. So again, basically takes two neural networks and pits them against each other. So uh, these two neural networks basically has what you call a generator network and a discriminator network. And these two networks compete. So the generator produces a new image based on the input. So back to the example of a sunset on the beach, um, it will basically produce a new image based on that input, uh, and say, well, okay, this is what I think a sunset on the beach should be. A discriminator takes that generated image and basically tries to decide whether it is real or fake. Like, is it really what we would determine as a sunset on the beach, or not, based on training data. So this is basically how it works. So you have the real image. Um, Images are used to compare against the generated images. So you put your input in, the generated generates a sample, which is basically the image that you want to create. Um, it then discriminator then looks at that image and the sample image, and basically makes a determination as to whether or not that really is what you wanted, and then shows you that image. And that way it cuts out all the noise, um all the images that don't really match, and tries to get you as close as what you want. The next method is using latent diffusion models. So latent diffusion models basically adds noise to an image over time until that image is no longer recognizable, until it's basically just noise. So the neural network is then trained to recover the original image by reversing the noise process. So when it reverses that, it basically now has a method to generate that original image from the noise. So uh, it's kind of like how this works. So if you took this picture of a dog on the grass, a white dog on the grass, it gradually adds noise to that until it gets to just plain noise. And then the model is trained to basically reverse that and go back to the original image, which is white dog on the grass. And this method can now be used when I ask it, um, how if I were to ask it, show me a picture of a white dog on the grass. Now it doesn't come back with this exact image, because it basically understands basically the technique and the process for getting here, not this exact image. The best analogy I could think of is, for example, if somebody shows you a chocolate cake, and then they reverse that chocolate, engineer that chocolate cake back to its original ingredients, and then shows you how to take those ingredients to go back to that exact chocolate cake. And now you know that process. So now if I were to ask you to bake a chocolate cake, you would know, well, okay, this is how I would go from this exact these um these ingredients to the cake. But your cake would not be the same as the original. It may have differences, variations, that kind of thing. But the process, and that's kind of how this training is done. And the last one is probably the easiest one, which is basic style transfer. So you use two images and you basically convert one image into the style of another. So for example, you could take a photograph and say, I want to, you know, convert this photograph into the style of this particular artist. So the model is trained to learn how this particular artist draws, their techniques and styles and that type of thing, their use of colors and objects and that kind of thing, and then takes this original image and applies that technique to get its interpretation of what this image should be if you were to paint it in this particular style. So the popular ones that we're looking at is DALI, which is from OpenAI, and that's probably DALI 2 is probably one of the more popular ones. Is a hosted service by OpenAI, so you could sign up and they give you a number of credits. You can buy more credits if you want, and then you put in a prompt and you generate an image. So it's probably one of the most popular ones, and probably one of the ones that came out, first with an amazing amount of accuracy in generating images based on what people want. The next one is Stable Diffusion. Stable Diffusion is an open source tool. Now, unlike DALI, which is hosted, Stable Diffusion, you could download and compile it yourself and run it on your local machine once you have the available resources. And you could download the models as well. You could also get services that provide hosted versions of Stable Diffusion. The differences between Stable Diffusion and DALI is DALI is more of a curated data set. So DALI does, OpenAI basically decided what images go into its data set and did their due diligence, on the things like copyright of the images and stuff like that. Stable Diffusion basically, anybody could generate a Stable Diffusion model based on the images. So it's a lot more open in terms of what kind of model you could decide to do. So there are a lot of people who would do things like create models to create anime and stuff like that. But the issue with that is the training material that is used. Sometimes, there are issues in terms of, do you have the rights to be able to use those materials to train these models, and we'll talk about some of those issues after. There's another one called Midjourney, which is basically uses a Discord bot as the front end. So you go into Discord and you ask it to generate an image based on a prompt, and it passes that on to Midjourney, and Midjourney will basically return the image for you. So with these tools, you can integrate them. So OpenAI has APIs now available for DALI 2. So you can actually, write your own applications and, make calls to DALI 2 to generate um, images based on prompts. Stable Diffusion as well, APIs can be built because it can be put on hosted services, and there are a lot of services that host Stable Diffusion instances and provide you with an API that you could use to use it. And that's actually one of the things that a lot of services doing now, because they have access to the computing power to run Stable Diffusion. A lot of people may not have that because the processing and RAM and that kind of thing needed to run some of these things can be pretty high. So how does this work? Um, well, text-driven image generation relies on something called prompts. So a prompt is like a natural language um, request for an image. So a prompt would contain like nouns and adjectives. It would contain like artist name, style, quality, the medium that you want. So for example, if I want again a picture of a car on the road, um, I want it in the I want it photorealistic. I want it in a medium of you know um, ink. I want it in the style of watercolor. I want it like done by a particular artist. Do it as if you were doing like a Van Gogh painting. That type of thing. You can do that, and the more detailed the prompt is, the better chance of it generating an image that you want. So let's look at um, an example. So this is an example of images I generated, one using DALI 2 and one using Stable Diffusion. And the prompt I used was photorealistic image of a female masquerader in Trinidad and Tobago Carnival. And these are the images, or some of the images I came up with. So it also came up with other images um, that you could basically curate. So you could say, well, no, that's not what I want. This is what I want. But these are I want some of the more accurate images that it came up with. And as you can see, I mean, it's pretty good considering all I did was give it this particular prompt, and this is what it came out with. So in a case like that, what can you use this for then? And the possibilities are there. For example, stock photography. For example, if you want a say you were doing a project or something, and you want picture of a cup of coffee, you no longer have to go through stock photography to do that. You can ask one of these services, or use one of these AI generation tools to generate a unique picture to you about that, right? And then you could customize it however you want. So you could do that with like product photography. People use it, in making like covers for books and comics and card games and that kind of thing. People have been starting to use it to do things like animation and video. And there's a lot more use cases coming out of it. So what I wanted to do was I want to use it for a project to see how it could be useful to me. And so I came up with a project called the Alphabet Project. So I have a lot of little nieces and nephews, and uh, a lot of babies who are at the point where they started to learn their ABCs and that kind of thing. I was thinking, well, it would be nice to like generate like a unique book of ABCs for them, right? So what I would do is basically develop something where I could generate a book of ABCs that is unique to them. So I used DALI 2, and it generated 4 images of each letter. So 4 images of A, 4 images of B, C, etc., etc. And then I also used it to generate a cover for the book, right? And then what I do is I use a Python script to generate a PDF based on um, these letters. So let me give you an idea of what that looks like. So basically, what I did is I have a JSON file which basically denotes the pages of the book. So first to last page, one page 1 to 26, A to Z. Um, what I also have is so I have a back page. Now, when you generate this and you're using it in Works, they say that you should, indicate that the images were generated with the assistance of AI, because there's a lot of controversy going on about, what being able to attribute the images and that kind of thing to the proper artists and stuff like that. And how does that work in terms of AI? So DALI recommends that you basically put something that says that the images in this book were generated with the assistance of AI. And if you want, you could specify uh, that it was generated with DALI too. And there are terms of services that you have to follow when you're doing uh, work with these generators. So also have a front page. Now the front page I generated the background, and then I went to a photo editor and basically added, Anil's ABCs. So a lot of these things it takes you 90% there. So like in terms of this artistic work and that kind of thing is not something I could do on my own, but I'm able to generate it. But in order to get it to something useful, there's also work that you have to do yourself. Um, in terms of the pages, so here I have 4 variations of each letter. So what it does is generates a book with a randomly generated number 1 to 4. So it randomly chooses one of these letters and puts them together uh, to generate the book. So if I were to run that, it would generate the cover, all the letters, and the back cover. So what I would end up having is a new book being generated. And well, I could tweak this, tweak the dimensions and the formatting of PDF and that kind of thing. Were I to send it to be printed, I would have to conform to the printer's specifications. So you could do that in the PDF specifications. Um, so here you could basically how determine how you're generating the PDF, and basically it will generate this entire book for you. And I could get this printed out, so I could do a book for Anil's ABCs. I could do insert the other people's names here, change the covers, etc., etc. So that's kind of one of the use cases that I'm looking at. So what do I need to do additionally? I was looking at adding additional images to the book. So instead of just the letters, you have like images, so a picture of a bat for B, that kind of thing. And you could use DALI to actually generate those images. Add a story element. So try to see if I could generate storybooks, especially books for older readers and that kind of thing, um, using the image generators. And that would mean like being able to learn how to define and use the prompts properly. So the next thing is, even though using these image generators is not 100% automated, there's still work to be done on my part, in terms of being able to put it together and that type of thing. So the AI art, um, this entire, I would say, revolution is can get kind of messy because it there's a lot of things that we need to to look at, uh, it, with the advent of this technology. And so when you look at, digital tools, in the timeline of things, firstly, art was just done by hand, right? So you would do a painting, you'd be doing that by hand. Um, then came digital art tools. So, you could use digital art applications, um, other tools, Photoshop, etc., to basically help you in uh, developing, artistic works. A lot of these tools eventually start to become more sophisticated. So you have like tools now that are assisted with AI. If you've seen like for example, the photo editors and that kind of thing in the new Pixel phones, with things like the Magic Eraser, where you could basically remove an object, remove a person from seamlessly from uh, an image, and the AI fills in the missing details. You have tools like that now, which assist people in creating in works on their machines. So AI is assisting them to do it, and then we have these tools which basically generate complete works of art based on prompts. Um, so you know there are ethical issues to look at, um, and tools like stable diffusion in particular came up against a lot of these ethical issues because of its open source nature. The fact that a lot of the images that you could have generated with stable diffusion, you could not have done with DALI. So people were able to generate images with celebrities, for example, and adult images, and a combination of both, which is not good, right? Because as the technology gets better and better, how do you discern what is real and what is not? And you could put people in kind of situations where you generate certain types of content um, with their faces and bodies without their consent. And a lot of these issues have to be worked out. Uh, Stable Diffusion 2, in particular, made some steps to basically take their data set and purge it of not safe for work images and purge it of celebrity images. So you can no longer generate that type of content. However, because it's open source nature, nothing stops somebody from generating their own models using their own data sets that they scrape from the internet or whatever, and doing that. So that presents an issue. There are also legal issues to worry about. So, for example, in terms of um, using artists' works to train models, how does that how does that work, right? What is the copyright issues um, that come up when you use that type of thing? Because in a lot of these models, the images are used for the training, but then those images are not retained, because once the neural network is trained, it's basically trained with the styles and techniques. It isn't necessarily doesn't keep the images themselves. They may keep like hashes and that type of thing, but the actual images are not retained. So in situations like that, how does things like copyright and stuff like that apply? And should you be using those types of images in the first place? You need to be able to get permission to use that. And the other thing is the copyright of generated images. Who owns the copyright of a generated image? Um, is it the service that generates it? Is it the user that generates it? And a lot of the legal frameworks, for example, in the US, simply doesn't account for copywriting of these types of images generated from a service like this. And some of the other things are, a lot of social issues come up. So how does it impact artists? Um, Artists themselves, I mean, they're seeing tools able to kind of duplicate their methods and techniques to create art that would take them time, energy, and effort, and would have taken them a lot of uh, time in terms of being able to get the skill to be able to do this. Whereas a neural network could basically learn these things and generate 100 pieces of art in this artist style, um, and basically flood the place. And a lot of the artists have you know said that it's difficult now to be able to see their art online, because you have all these other images being generated by these services in their styles, and their art gets lost in there. So what happens then? What happens if, when you're generating images in the style of other artists, if I were to train um, a model to uh, paint the way a local artist paints, right? And I generate art from that. What is the what is the impact of that, right? Is that you know an ethical thing to do? Is that something that should be done? And there are a lot of these issues that are coming up, right? And we as software developers see parallels to those issues too. We see them in terms of proliferation of AI and no code generation tools, in terms of tools like GitHub Pilot and that type of thing that do AI assisted coding. Um, I've been coding for a long time. I've been developing software for 20 plus years. So I mean, I could be like the old man in Simpsons, raising my hand saying, I used to do these things by hand, barefoot uphill, that kind of thing. But the truth is, technology has reached to the point where you know somebody could basically go and knock up a application and do the same thing that only I could have done 10, 15 years ago. So um, these are issues that we kind of have to work out. And I think in the future, where do we go from here? I mean, do we call ourselves artists now in the same vein as the can anybody call themselves a software developer now? um, what is the impact of this technology? Because the thing is, the technology is here. So the horse is out of the barn already. So the question is, what do we how do we rail against it? Do we find a way to live with it? Do we evolve with it? And these are all kind of questions that we would have to ask ourselves. But I mean, in terms of the technology itself, I mean, there's a lot of um, possibilities and use cases for it. um, I haven't ventured any commercial ones because of I'll wait and see how a lot of these issues shake out in terms of the reactions of artists and that kind of thing. But I mean, there's a lot of possibilities here. So I mean, I would encourage people to sign up to some of these services. A lot of them are free now. Um, if you have like a Microsoft account or Google account, you could sign up to DALI 2 and generate images there. I think you get like 50 credits or something like that. I'm not sure what the amount is now. When I signed up, it was like you get a number of credits and you could generate images. Stable Diffusion is available. There are a lot of front ends for Stable Diffusion now that allow you to download that front end, and it will do all the work in downloading models and that kind of thing, and provide a nice front end for you. There's one called Diffusion B, which is nice if you have like a a Mac with an M1 and M2 processor is, pretty good. Uh, the 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 performance is pretty good on those processors. So, I mean, you could go online and explore these things, but also be mindful that there are a lot of issues surrounding it. So, you kind of have to just be mindful of how you exploit this kind of technology. And that's basically it for me. Thank you very much. Uh, it was good to be here again and do this presentation for you.
Awesome, great, Anil. Thank you so much for that. It was really in depth. I think any questions I might have thought of, you would have got ahead of it. But I am really concerned with the ethical issues. Would artists have to be afraid of thinking about how they license their art, or how people are permitted to use their art, for instance, to train in these kind of AIs? What should they be thinking about?
Yeah, well, that's one of the issues is in that, in terms of training these AIs, things like DALI and stuff like that, they curate the art that they use. OpenAI curates it, so they basically control or get the permission of um, the artists that they use to basically um, generate their models. So in terms of services like that are tightly controlled, the copyright issues and that kind of thing are dealt with in terms of dealing with the artists. Something like Stable Diffusion, where anybody could do it, it's a little more iffy because it's a little more open. Stable Diffusion themselves have been able to, like, they've taken steps. For example, like I said before, they've removed a good amount of content from their models. um, they also working on processes to allow artists to opt in or opt out of being um, part of model training and that kind of thing. So it's a work in progress. If you're an artist, I mean, the thing about it is two sides. Yeah, it is two sides you could look at it. There's the side where it is a threat, and but there's also the side where it is a tool, right? So so for example, the same thing like when we look at something like GitHub Pilot, where it's not going to develop a fully formed application for you, at least not
Mhm.
yet, but it could do a lot of the heavy lifting. And in terms of artists, you could look at it like that. Like, it does a lot of heavy lifting, but you have to, go the last mile to make it, a unique and compelling piece of work. So, I mean, it to me is a lot of, you know, based on perspective. Um, but in terms of copyright issues and that kind of thing, I mean, that is an issue. I would, look at how things like OpenAI does it. Because their stuff is a little more controlled.
Okay, great. So it's good to hear that these more popular platforms at least taking the ethical approach in that they're getting the permissions of the artists. And I definitely agree with you. I could see it, those two different perspectives. It's like it's going to replace me, or I can actually use it as well to actually make my work easier or better.
Yeah,
Thanks
because
again
because
for. Oh, sorry. Go ahead.
oh, sorry, no, what I was saying, because I see it from both sides, right?
Hmm.
Because for me, I see it from the side of these tools provide me with the ability to create things that I could no longer create, that I could not have created before, right? Um, so it opens up an entire new avenue for me to apply some of my knowledge in programming to create something that I could not have done before, because there are aspects of it that I were not able to do before. So for me, I mean, it opens up an area for me that I could do. But also, I could see from the artist perspective. I mean, if you spend your entire life working, honing your skills, learning your techniques and that kind of thing. And then Anil show up and he can't draw for crap and then run a model overnight and all of a sudden he's an artist. I mean, I could see how people would be pissed off. That's why I hesitate to call
Yeah,
myself that. I'm just a user at this point. So, I mean, you can see both perspectives.
yeah, definitely. Thank you so much for speaking in this year's DevFest. Any final words?
No, no. I mean, I'm glad to be here, and I'm glad that this keeps continuing every year.
Yes, of course. We will always try to run it as much as we can. So thanks again. Bye.
Sure. Okay. Right.
All right, great. So that was another great talk by Anil. Anil is another one of the speakers that we have seen in time and time again at our events, and we're very happy to have him talk for us once again. So now we're heading into the last presentation of the virtual track. Remember, we still have our in-person track later today at the Dalai Lama One Woodward Place. So I'm now going to introduce our next speaker, who is Shannon Clark. Right, he is an electrical and computer engineer. After 7 years in the utility and construction industry, decided to focus on building technology products to empower individuals and build communities. So Shannon is a first-time speaker for the Devfest, so we would like to welcome for the first time Shannon Clark. Hi, Shannon, how are you doing?
Hey Nicholas, I'm doing well. You can hear me well?
Yep, you're coming through perfectly. So yeah, as I said,
Fantastic.
welcome to the Devfest. How you feeling about the event so far?
Well, yeah. Well, thanks for having me. I think it's a fantastic event, and I hope I can share a little bit about what I've been playing with. I hope everybody's having a good time as well. So if
Awesome.
anybody's really ready, you can just start up a code editor, and I can share a bit about what we've been playing with.
Okay, great. So so you can just tell us a bit about what your talk is going to be
Oh, sure.
while you bring up the screen share, maybe.
Yeah, sure, no problem. So basically, we've been hearing a lot about using artificial intelligence and also the difference between like machine learning, deep learning. How can we actually apply these within our own applications? Is it going to replace us or is it going to make us better? So
Mm-hmm.
I'm just going to show like a really simple example of applying a simple set of available machine learning models that Google actually provides using their TensorFlow library. We'll be using that in React. And then there's also, so I have some walkthroughs as well as some sample code. And for React Native itself, I actually found that Expo already provides this information already. So a couple links included in the presentation, but we'll go
Okay.
through it.
Okay, great. So yeah, without further ado, you could get right into it. To share.
Yeah, I probably could just start
Just
sharing my
just
screen
yeah,
directly.
just going to present down there. We'll bring it up on stream.
Let me
There
know
we
when you can see
go.
my screen.
Yep. So you can take it away.
All right, fantastic. All right, thank you so much, Nick, and welcome everyone. So, as I mentioned before, we're going to really be going in a bit about how we can actually leverage machine learning with React and TensorFlow. Now, typically, a lot of these models, the machine learning models, is only available if you're building directly on a server, or if you're building maybe in a different language, such as like Python, for instance, or more recently, Go, for instance. But now Google has actually made it really available for us to not only build and train these models, but also access and execute models even within your browser itself. So just a little bit of foreshadowing. What we're going to be building today, we're basically going to be building something very similar to what you're seeing there in the animation. That's a quick GIF of like it's just very showing my webcam, and we're taking the video stream from the webcam and then detecting what the objects are. Now this is using a available machine learning model called Coco SSD. Now that itself actually that's an acronym, but it actually uses different libraries within it, MobileNet, V1, V2, and it has different levels of accuracy. I'm going to let you do the full research into that because we only have limited time itself. But one of the things you'll probably notice is that it's actually identifying my cell phone as a cell phone, then me as a person, but it's not identifying some of the objects in the background. There's some limitations basically to doing on-device detection, such as this, but there are also other models that you can utilize as well. So let's dig into it a bit. So I definitely don't want to go too deep into the definitions, but this is a great like high level view, really and truly. Basically, machine learning is kind of what the actual words are. It's basically machine basically learning over time based on its own performance, but you're really feeding information into it. Now, the way how that works itself, we'll get into shortly, but I do want to actually highlight that when we talk about artificial intelligence, that's actually a broad category. A broad category, just as you're seeing in the Venn diagram there. And within learning, within artificial intelligence, sorry, then there are different subsets, such as machine learning, as well as deep learning itself. So if you just read from the diagram itself there, we're saying that we're basically making sure that computers actually can, over time, learn, but also learn, sense, reason, act, and adapt based on the input. Now that's really important part there, and we're going to go a little bit deeper. So just take in mind that we're actually focusing on improving performance by continuously incorporating new data into an existing model. That means that the more information that is artificial intelligence is fed, then the better it becomes. So initially, most computers are just input output. But the important thing here now is that we're actually able to take that output to then feed back into another set of input. So again, then going further then. So if you look at the diagram on the right here, where we're talking about, so we're first talking about two phases then as we're building a machine learning model. We're building up this form of artificial intelligence. First, we need to train it. Remember I said that most computer programs are input output. We all know those as functions, basically, maybe classes, other ways that you can refer to them. But what we're really doing here now is that you have to train your model then basically. You're training something called a neural network, and that then becomes a model. But what we first want to do is that we want to give it some information. Let's say in this case, we want to be able to identify a phone, like what I was showing you before. And if I want to identify a phone, then I want to show it examples of phones. And then, so that would be the answers that you're seeing above. And then also want to give it some data in terms of, well, what are these phones? Over time, then it'll be able to determine, okay, well, this is a phone, this is not a phone, and then it'll be able to apply weights in terms of if I then send it another set of information like a cup, then is this a phone or not? Now, based on that model that the computer would have then provided, well, would have then built up, the neural network would have built up over time, then that will become a model. Then, in which case, then it can determine if this is a phone or not, even though it has a similar shape. Is it a phone or not? With that, then maybe give it new data, such as then pen, into the model, which you're seeing at the bottom, that's the inference phase, then it can make a prediction. The thing is, ultimately, is that we don't ever expect that a prediction will be 100% true, right? The computer ultimately is trying to get towards that 100%, but we never really quite get there. So a couple of use cases that we do have, typically when we're using machine learning models, question and answer chatbots, we see the most very popular example of GPT very recently. That itself is actually understanding human language, but then also responding in a way that's very human to us. So a lot of things are happening there. Detecting objects and images in images and video, that's essentially something I'm going to show you now. Sentiment analysis in text and audio. If you're then trying to find out, well, is this like what kind of emotion was being expressed within that text? Not just reading the text as what you're seeing with a lot of response chatbots, but also understanding that text. And based on that, then determining, okay, well, what was the user actually intending? What is the tone? We often hear that within, if you're texting someone or if you're sending instant messages, that the tone is often lost. What if we can actually use these models then in order to actually identify what the tone was? Generative art, for instance, we're also seeing in terms of, I'm sure everyone here would have seen the Lensa app. That app then itself also does a very similar thing. Over time, that model or those models that are being utilized would have been trained on various forms of artwork in terms of identifying, well, what is art? What is a particular type of art? How would that art actually be applied? Maybe even how it's even interpreted over time. and then how that art then can then be applied to different artwork, so that when you feed your face into that model, then it can then provide out other information out to you, basically generate new forms of art. So there's a lot of things that we could really do with these machine learning models, and I think we're only at the very very start of where we could actually go. And one of the ways in terms of pushing the industry forward, Google and many other companies, quite frankly, have been making these models more accessible to the general public, like you and I, and also not only so that we can play with them, but also so we can contribute to them. And that's where then we get to TensorFlow. So I have a little brain icon here because we're actually able to work on a brain essentially. I, I really like to think of artificial intelligence in that way. Like we're really teaching this little I hesitate to call it a child, but essentially like a little baby computer, then a baby brain, basically, how to think and how to understand different things. But as we all know, garbage in, garbage out. So we really want to be able to figure out, okay, well, how do we ensure that these brains over time actually get better? And TensorFlow is basically a system, really, actually a library that Google has then provided, made free and open source for anyone to use, for us to actually build, train, and actually deploy these models as well. Now, we'll be using this in browser. This is a client browser, so it's actually on your browser. There's no server side to this at all. But TensorFlow itself can actually be deployed in various platforms, across platforms, really and truly. Now, there's actual TensorFlow Core, then there's TensorFlow Lite, TensorFlow Cloud. And I'll be happy for you to actually take a look at the website that Google has up. There's a couple of links at the end of this presentation so you can see the wide gamut of what you can actually do with TensorFlow. Now, when I mentioned that in terms of we're actually going to be using this in order to build machine learning models, then, well, what about the existing models that we actually have right now? Are there any models that you can utilize right now? Fortunately, yes. So Google itself actually provides several models that we can utilize. These we're seeing here, you can see the source link as well. We actually have some models that we can utilize directly within TensorFlow JS itself, but you can also convert any model out there that's available. There are many models on GitHub, for instance, on huggingface.co. Probably should have dropped a link for that as well. And there are a lot of open source developers out there that right now building and training their own models and deploying them, but also making it open source so you can then also extend upon them as well. And we see a couple of examples here in terms of image classification, object detection, pose detection, for instance, various things as well. I actually should say that one of the perhaps one of the use cases I really should have included there was really like detecting, let's say, illicit content and illegal content, like for instance in video streams or photos, for instance, so such as nudity, such as X-rated content, etc. We can actually do that as well using just very very simple image classification techniques. So we're going to get started with coding, and basically what we're going to do, just as I mentioned before, we're going to utilizing your desktop's webcam. This could potentially be run on your phone as well, but it would be using your phone's browser. And we're going to be overlaying the predictions on the actual webcam displayed. A couple prerequisites, if you do want to follow along, you do need to have basic knowledge, shouldn't say expert knowledge, just basic knowledge of JavaScript and React, and just a basic understanding of the HTML canvas. So there's some starter code here, and there are also some step-by-step instructions that you should see at the Notion link. That link should be public to anyone. I think I do have it up there, but if you have any issues with it, feel free to reach out to me. I'll share my email towards the end. You should be able to also reach that link by scanning the QR code as well. So I'm just going to walk through a couple of these steps, and then maybe I can then share my screen again just to show you like a quick demo as well. So we're going to do a couple of things here. First, we're going to configure. Well, if you're using the starter project, you would have started with create React app and just start that boilerplate. And then first thing we're going to do, we're going to use the React webcam library. in order to actually trigger our webcam. And using that, we're going to just configure it just really quickly. A few things here. You're going to see video constraints. You're going to see facing mode, which is towards the user. We want to do a bit of image smoothing. If you have maybe not the best webcam, kind of like mine. And then also, in this case, and I'm utilizing Tailwind CSS, but you could really utilize any CSS that you wish for. The webcam component actually takes not only the class name prop, but also a style prop. So you can style it however you so desire. And we're loading a canvas, HTML canvas here as well. Now, we're adding some refs here just so that we can update the current element within the DOM itself. You would understand what I mean if you have understanding of JavaScript and React.js, but essentially every web page itself is really a structure of different elements, and we call that the DOM tree, document object model tree. And within that tree itself, then we can actually, what we're doing here is that we're manipulating this DOM tree in terms of including these special elements here, which you're seeing, let me just go back, which you're seeing is the webcam object as well as the canvas object. So I'm just basically adding two references here, webcam ref and canvas ref, so that I can manipulate those objects later. In first case, I want to be able to grab the content being provided, the stream being provided from the webcam, as well as then in second instance, be able to manipulate the canvas so I can display the predictions. So the three configurations, I'm going to use the front camera, I'm going to play image smoothing, and I'm going to mute the audio. Muting audio is kind of optional. So now we'll get to the fun stuff. We're going to load the TensorFlow model. And once we've loaded the TensorFlow model, since it is JavaScript we're working with, we want to make sure that things are happening synchronously so we don't have any blocking operations. So we're going to load the TensorFlow model as well, load the TensorFlow library, sorry, and then we're going to load the Cocoa SD model. And once we've loaded that model, then we're going to wait just to make sure that everything's loaded and then start handling the camera stream. Bit of a code soup here, word soup here, but essentially what we're doing is that we're grabbing the current camera stream. You're seeing this here on these lines here, where this is get video properties. We're grabbing the current camera stream. And once we've grabbed that stream, then we're using it just in order to adjust our canvas. And based off of that, then we're able to then start processing the video. We're processing the video. In this case, net is the loaded model, the loaded Cocoa SD model, and we're running the detect method. Most of the magic is actually happening right in this line. And this is synchronous operation where we're detecting the video from the video stream, and we're grabbing any predictions from it. The predictions are actually stored in this variable obj. Once we've done that, then we're utilizing a utility library called drawRect in order to then actually output the predictions and overlay them directly onto the camera output. This is essentially the drawRect utility that we're utilizing to display the predictions. This is very simple in fact, but all we're really doing here in this case is that we have an array, which was, you remember that we just had the obj object, that's an array itself. And we're going through that array then to grab the bounding box for each entry, each of those detected or predicted objects, I should say. And then we're then using that in order to then create a box that then has the overlay title on top of it. That was where you were seeing before the person, cell phone, etc. Now in this case, then we're doing something a little bit funny where we're just randomizing the actual color that's shown, and that's why it's flashing in different colors over time. So the final result you should be getting is essentially what you're seeing there, where you're seeing me holding up a cell phone and you're seeing a cup as well, but you're also seeing that person is showing behind there. So in this case, once the camera is actually able to get, once the model is able to get a full resolution, or better resolution, I should say, of the object itself, then it's able to detect it. But you notice that in this case, then it's not detecting the chair. Well, you're not seeing the chair behind me, but it's kind of picking up. If you look really, really closely, it's picking up the potted plant. And before, you may have been seeing that it was picking up on the screen that I had in the background as well. So there's a couple limitations here. Now, Cocoa SD is indeed like a well-known, a well-trained library itself, but it is limited in terms of the number of classes, the number of objects, I should say, that it really is suited, or best suited to detect within either video or images. You can also use it to detect in terms of still images itself. Uh, and this object detection doesn't really work too well for overlapping items, which we just noticed. And of course, there are also limitations in terms of running your computations client side, such as you're running it ultimately on the device and you're dependent on the browser. And if you have other things that are going on within the browser, or if you're limited in terms of the bandwidth or even the CPU hardware, then that's an issue. Now, there are a couple of alternative tools that you could be utilizing, and also most of these are really libraries and some other frameworks as well. So there's OpenCV, there's PyTorch from Facebook, or should I say Meta in this case. There's a Google Vision API, which is quite amazing, frankly. However, that may incur some billing itself. So it's not entirely free. I think it's pay per use. And Firebase itself actually does have a machine learning kit. However, it does seem to be being deprecated to some degree. I haven't seen the most recent libraries really supporting it. And it seems that most persons are instead opting to depend on the Google Vision API. Tesseract is an older library that's been used in different ways. It actually includes and references other machine learning models itself. And it's pretty good for OCR as well. I could also share an example of utilizing that. So if you do want to grab some of this code for the React JS, that's for the web-based version of it, you can grab it at this link on GitHub. There's also a publicly available template provided for React Native. This is specifically using the Expo framework. And in this case, then they actually are showing you how to actually leverage TensorFlow, but not just using the TensorFlow JS library, but also using a version of it for React Native. And they have a particular component there, in which case you're able to then leverage that for your device's camera. So some further reading, if you do want to go into it a bit more, there's a free online course from Coursera, which does take you into TensorFlow. I always recommend that you go deeper into the actual documentation itself. And there's also a very helpful helpful tutorial here running OCR within the browser using TensorFlow. And that is actually that's using a different model from a company called Mindy itself. And they also provide source code as well. So you may want to take a look at that. So that's about it on my side.
Awesome presentation, Shannon. Thank you so much for that. So this is on device ML, is that correct?
Yeah, that's it. Yeah. So it's actually within the browser itself. But if you want to actually run it directly within your device, you could use something like TensorFlow React Native.
Right. So you're using TensorFlow JS, is that correct?
Yeah, that's correct.
So when the page loads, it's going to initialize the model, basically retrieve it as what? How is the model stored on the device in the browser? Is it some kind of proprietary file that works with the website code?
Well, in this case, since it's using JavaScript, now I'm using ES6. I'm importing it as an npm module. And really and truly, once I import that module,
it's bundled.
Exactly, it's already bundled.
Wow.
It's already bundled, right? So it's actually crazy. It's actually crazy how easy that is.
Yeah, so the model is just a bunch of JavaScript that's in the browser. It's just any regular JavaScript file.
Well, it's been converted. It's been converted.
Uh,
So ultimately, though, what you may notice, depending on where you actually try to deploy like a live application, then you may need to configure your bundler accordingly. So, for
mm.
instance, Webpack is a little bit different from if you're using another bundler.
Wow. So that means if you're building like a progressive web app, you can still launch that page offline and do offline ML. The model should still work.
Actually, yes. No, there's TensorFlow like which is better for offline, like fully offline.
Hmm.
And in this case, we are still referencing things online. But yes, you can actually still you can still do fully offline processing using TensorFlow.
Yeah, that is really a mind-blowing aspect, especially for the web. Like, what is one thing if it's a mobile app, you have much more leeway in terms of the footprint of the application that you can store on disk. But to think that you could just load up a web page and run a model that has been trained with all of this data and is actually performing object detection, I think you could do some really big things.
Yeah, so you can imagine how useful that could be. For instance, let's say there's like a business, for instance, that needs to process maybe their I don't know checks or something, or even as an individual, right? You want to process like your different receipts, then you could do that entirely offline. Or if you want to have like an offline version of Chat GPT, not that it's offline right now, or that not that you can get to that level right now, but the great thing though ultimately is that what we're doing is that we're actually compressing all that computing power into a simple model that can then be deployed wherever. And that's really the power of what Google has provided with TensorFlow. So they have different adapters, basically, is a good way to think about it, where you can
Mhm.
then use it in different areas. So, TensorFlow, you can, when they first open sourced it, a lot of the work was happening in Python, for instance. But now you can actually code. You can code and train an entire model just using JavaScript.
Yeah, that's always like the wild concept for me for machine learning is that yeah, not anyone could build a model and train it because it's really process intensive. You need a lot of processing, you need a lot of data. But the end of it, you get the model that's lightweight that could almost run on any device. So it's an interesting way to take all this processing and then distribute, the value that it provides to these devices. And I think that ability of ML being more available is really going to revolutionize things.
Well, yeah, but let's not forget that there's still some caveats involved.
Hmm.
So, for instance, if you're actually first you have to load the model within the browser, which is its own challenge itself. And then, so yes, you're bundling it, but then you still have to load it. So you still have to load it into the actual browser session itself. And
Hmm.
then if you're then training the model, for instance, it's going to take a lot longer. And then you're also going to have like let's say if you're security issues. So if it's for whatever reason you have proprietary um, something in terms of how you're actually training that model, then if you have your model within the browser, then well, anybody can take a look at it you know
Yes, true. We
so
definitely have those considerations.
so there are some caveats to be considered, and there's still always a good reason to move certain things over to the server. However, build to this, let's take it this way, is essentially one portability for the end user, but then also making it more accessible and more available to a wider gamut of developers by having it available as TensorFlow JS. But I don't want anybody to think that TensorFlow is only for JavaScript. I'm only demonstrating the JavaScript part of it here, right? But really and truly, you have adapters across the different libraries, different languages.
Yep, sure. So we talked about on-device ML, whether it's offline or online, but we could also access ML over cloud services. So I know Firebase has extensions and whatnot. Have you have any experience with those kind of services?
So I do have a lot of experience with Firebase. So
Mhm.
Google Vision API. I was actually thinking if I should have shown a demonstration here, but so there are a couple of things with regards to the Google Vision API. One, it's dependent on your online connection, and then two, you do have to actually set up within. You do have to set up your access and your credentials using the Google Cloud API,
Yeah.
well, using the Google Cloud platform. So it is a bit more setup involved in that. In my opinion, when you take a look at the available trained models for TensorFlow versus those that are already available using Google Vision, you're going to be really, really surprised. Like Google has already provided some really, really accurate models. Like they don't have the issues that you may see when you run this example locally, because as I mentioned, Coco SSD is limited. It's limited. The mobile net V1, V2 that is, depends upon those are limited in terms of what objects they can classify. However, Google has trained their models on way more objects, and the accuracy, as I mentioned before, is way higher. So, in my opinion, there's that trade-off. If you want to build your own models and you want to be able to be dependent on your own training and you want to train on your own specific information, that's where, in my opinion, TensorFlow and its alternatives really come into play. For instance, if you want to, I think there was someone at the time that was trying to detect if it's a roti or if it's not a roti, or if it's a mango or if it's not a mango, right? Maybe Google isn't going to do that, but we could.
Hmm. Yes, I think definitely being able to take the models in our own hand, having control it, could really tailor it to our specific use cases. That isn't to say that the cloud models aren't really good and useful on their own and not have a lot of wide region applications. So I do know with the Firebase extensions, those models could do things like barcode scanning, object detection, and translation. So it will see text and then cheat and actually translate the text in a in your local and whatnot. And they actually have the added advantage because, as we were saying before, the model is lightweight, so it could run on a device. But with the cloud, we don't have that limitation. We could run as big as a model as we want. And if we're thinking about optimizing, maybe we cache results for requests that our users are commonly searching and whatnot.
Yeah, exactly. I would always advise, if the intention is to get our application up and running and we have like a particular use case in mind that may not require customization, then leverage what Google has provided. The Google Vision APIs, in my opinion, are top class. I really wanted to show in terms of what we could do on our own though, and but yeah.
Mhm.
There's also PyTorch. I'm not too familiar with them, but I do know that the Facebook team has been doing a lot of work. I'm not sure if it's also available for running on the browser client itself, but I do know that it is available across different platforms
Yeah,
and it
and
can be deployed. So like the powerful thing here is that you can actually take a model, let's say from huggingface.co, where you have a lot of open source models. You can convert that directly for use within TensorFlow JS, and then you could, or just for use in TensorFlow, and then you could deploy that on your device.
Mhm. Yes, I know there are other platforms like, well, PyTorch you mentioned, but I know Keras is really
Right, Keras.
popular as well for this ML stuff. Well, Shannon, I really want to thank you for bringing us to the end of the virtual session. Any last words you want to share with the audience?
Uh, Thanks for the opportunity. And in my opinion, if you haven't been taking a look into artificial intelligence or how you can train your own machine learning models because maybe you feel a little bit overwhelmed, take advantage of what is already available and try out different things. So just encouraging people to try out, experiment, and learn.
All right, excellent. Thank you so much, Shannon.
All right,
See you
thanks.
next time. All right, so there you have it, folks. That is our afternoon track, our virtual track, which is about coming up to the end of the proceedings today. Where we get a little background music. I just one more thing I want to share with y'all. Let's get that a little softer. Right. So remember, Devfest Caribbean is a multi-day event. This is day 3, right? So you have at least 2 more days, or at least one more day left with our last chapter. That's GDG Georgetown of Guyana. Let me share my screen right now, really quickly. I encourage you to go on devfestcaribbean.com. This is it here. Right, so you can see our full agenda, right? And of course, the recordings from the previous sessions are available here as well. And you go down to the RSVP links, it will take you to our various event platforms. We could RSVP, see the agenda, and see how to catch the various events. Okay. So with that, I want to thank everyone for joining us. Thank you all of our speakers, right? And make no mistake, you might be seeing my face a lot. Devfest Caribbean is a joint venture with all of the GDGs and organizers across the various GDGs of the region. All right. I want to give special thanks to my chapter organizers. We have Maria, Chantel, and LaShawn. They really help us, pull off these events. And of course, to my counterparts in the region. So we have also Somia, and Somia is actually backstage right now. Excellent launch to her chapter, as well as Jean-Pierre, who launched his chapter in day one. Of course, Gray is the GDG organizer and Stephanie for Guyana, Georgetown, and we will see them in the next day. Right. So with that, I'll bid you all farewell for now, and can't wait to see some of you all who'll be joining us for the in-person portion, 6 p.m. today at the Dalai Lama One Woodbrook Place. So with that, thanks, and I will see you all in the next one.